Okay, hello all, welcome to this video on exercise 14J, where we're going to look at sketching graphs of y equals a sine and plus or minus b and the equivalent cos graphs. Now, one thing to note, you might be realizing one class already told this, but the other class doesn't know yet, but we're not doing 14I anymore, so we're not going to bother with horizontal translations. Okay, you'll cover that in year 12, but for year 11 we're just going to stick with plus or minus b on the end. Okay, now I've left all these slides the same as normal, what you would have printed, just so you can see changes as I make them on the fly. So at times it might get a little messy, but I thought this would be better than making the changes all ahead and then forgetting to point one out. So straight away we can cull that off. Okay, the thing to note, if there is a plus or minus constant inside the brackets, that's effectively a horizontal translation. Just a bit of background information, so that's pretty much what we're going to be cutting out all the time. In front we have our amplitude as normal. If we have 2, and this could also be written as just 2t because we don't have horizontal or vertical translation, so it doesn't need to be factorized out. That's a really important thing in horizontal translation. And then we have a constant at the end. So just like in all of previous functions we've looked at, subtracting something off the end, that of course reduces the y value, which effectively moves the whole graph down. If we add something on the end of whatever to all these operations, we could think of it, all of this is generating a number, and then at the end we're taking away 2 from it, so it's going to make it smaller, of course, which would move it down. If we add 2 instead, that would make it larger, which would move the whole graph effectively upwards. We still have our period, which is 2 pi on b. Should be n, sorry. Yeah, not b, that should be an n. And then our domain, which would actually be wrong in this case, it is 2 pi on 2. So our domain will be from 0 to pi. 2 pi on 2 is just equal to pi. That n value. Okay, there we go. And then, like I said, this is the last new bit, which is effectively just move the whole graph down. So let's have a look at some skills when it comes to sketching. So the best trick to work through, or process, okay, is to state the amplitude. Okay, and remember, amplitude cannot be a negative number. Okay, it can't be negative. Even though the sign might be negative there, amplitude is just a measure of magnitude or size. It doesn't have a direction per se. Okay, so amplitude itself can't be negative. And we also use it to help establish the range of the function, find the period, which is 2 pi on n, find the endpoints, okay, which I'll show you in the example on the next slide, and then find any x and y intercepts where present. So this is step 4, is as Mr. Schaffner was showing in class, that is effectively solving circular functions. Okay, by either letting f of x equals 0, that's finding your x-intercept, or let x equals 0 to find your y-intercept. Will be your x-intercept, that will give you your y-intercept. Okay, we won't have to worry about this. Okay, this last step here, factorizing the trigonomic identity, because we're not going to be dealing with any horizontal translations. But if there was for some reason, okay, you actually have to take out the common factor. You need to get whatever the variable is, needs to have no coefficient. But we don't have to worry about that since we're not dealing with horizontal translations. And I'm going to keep saying that over and over and over. Okay. So sketch the graph of y equals 2 sine 2x plus 2 pi on 3 plus 1. Okay. So delete all that out. So we could delete that all out. So we could write it as y equals 2 sine 2x plus 1. Okay. So the period is equal to 2 pi on n, which is 2 pi on 2, which gives us pi. Okay. Now the endpoints. Okay. It asks us to show one complete cycle. Now, since we have no horizontal translation, that's really easy. We've got our period, so we know one cycle will be from 0 all the way to, in this case we're dealing with x, okay, whatever our period is. Okay, that will give us one cycle. All of this talks about, because we've been translated when rewritten over here, but I've rubbed it out, okay, it's effectively been translated pi on 3 units left, so we can ignore all of that. So we can ignore all of this, okay, and solving those endpoints are incorrect, okay. So we've said, I'll put it here at the side, one complete cycle, well, since there's no horizontal translation, it's going to be from 0 up to the period, will give us one cycle, okay. So our left point, right, okay, we need to let x equal 0, so it follows on, and we just need to solve. We need to solve the equation for y, so y equals 2 sine 2 by 0 plus 1. I'll change colour because probably the green's not the best to read. So y is equal to 2 sine of 0 plus 1. Y is equal to 2. Now sine of 0, that's the vertical component of an angle at 0 degrees, while 0 degrees is straight across it, has no vertical side, so that'll be 0. 2 times 0 plus 1. Y is equal to 1. Now we do that again, we'll let x equal pi, so it follows on that y is equal to 2 sine 2 times pi plus 1, y is equal to 2 by sine of 2 pi plus 1, y is equal to 2 times. Now sine of 2 pi, so again, what's the vertical component of an angle of 2 pi? Well, 2 pi is straight across, the vertical component again is 0, times by 0 plus 1, y is equal to 1. Okay, so we've got the same start point, end point. So we've got 0, 1 as our start point, and then our end point is 2 pi, comma 1. Now, it actually makes sense that, I can get my red, that is 1 and that is 1, that they're the same value, because we're doing one complete cycle. So we're letting the graph repeat itself, and we know a sine graph is like that, and one cycle, it's going to get back to the same vertical height. Okay, so sketch the graph y equals showing one complete cycle. Now we need to find the x-intercept. So we're not dealing with that. So the x-intercept, we need to let y equal to 0. Just like always, back from linear relations, we know that. Find the x-intercepts, you just let y equal to 0. So we get 0 is equal to 2 sine 2x plus 1. We get negative 1 equals 2 sine 2x. And we get negative half is equal to sine 2x. Okay. Now, there's two ways you can go from here. There's creating a working domain and solving that way, which is in one video, or there's doing the true substitution. That makes it a little bit more obvious. So I'm going to do that. So just quickly, so we're dealing with where for one cycle we know the cycle is going to be between 0 and pi. So that's still true here for x pi. Okay, so I'm going to let 2x equal to alpha, just to make life a bit easier. So it follows on that negative half is equal to the sine of alpha, or, and this is where we need to convert our domain. Okay, so we're going to convert. So we use this substitution, we're going to sub in 0 into 2x, so we get 2 times 0. Let's sub pi into times pi. So we get our new domain, or effectively our working domain, as 0, 2 pi. We need to solve negative half is equal to sine. Oh, or little fishy symbol. I don't mind what you call it. Okay, so we need sine of what angles? So alpha is equal to what? What's it equal to? 4. That gives us negative half. Okay, so we're effectively doing this. Okay, what angles give us a vertical component of negative half? Well, we can draw a little sketch. I need a vertical component of negative half, so the only lines that will do that is there and there. So that is going to be the same as, let's do the first one in blue, that's going to be pi plus now sine of what angle gives us half, sine vertical is pi on 6, and then the next one is going to be 2 pi minus pi. Going all the way around there. Which, when we simplify, that's 7 pi on 6 and 11 pi on. Okay. That's our alpha, but we need to convert it back. Okay, we need to solve for x. So if 2x to that follows on that x is equal to alpha on 2. Therefore, x is equal to 7 pi on 6, 2, or 11 pi on 6 on 2. So that will be 7 pi on 12, 11 pi on 12. And now, does that fit within our original domain? Yes, it does. 7 pi on 12 and 11 pi on 12 work. So they are our X-Intercepts. So our endpoints we need to fix up. That was pi, and our endpoints we said was 7 pi on 12 and 11 pi on 12. Okay. Now the fact that we're dealing in subsets of 12 would make sense to graph this because we're dealing in one cycle. As it says here, always count horizontal squares. I'm going to try and use 12 squares for one period, because then each, as if my period is equal to pi, then one block can equal to pi on 12. I use 12 blocks. Okay, so let's do that. Okay. 1, 2, 6, 5, 2, 7, 8, 9, 10, 11, 12. That will be pi. This is going to be pi on 3, no, not pi on 3, pi on 4 would be 3 pi on 4. That would be pi on 12. And goes on and on and on. Okay, 7 pi on 12 will be right there. Right, okay, so we have an amplitude of 2, a period of pi. Now, a thing to note here is amplitude of 2, a period of pi. So if we, before we think of our translations, okay, before we think of our vertical translation, amplitude of 2 for a sine graph, okay, that will go up to 2, that would be -2, okay, that would be pi, okay. But our whole graph has moved up, so we could think of, let's think of our key points, okay, visualize moving these 5 key points all up 1. Okay, so just doing a little sketch to show what's going to happen. Okay, there's our axis. We're effectively putting in, we could think of the working x-axis, okay, where it repeats around, what the amplitude is rotating around. So let's move up everything by 1 just to get a rough idea. So we could, okay, we'll figure this time. Okay, so this is 1, that's a height of 1. That means up there needs to be 3, that's at the height of 1. This needs to be height of -1. Okay, that's where we can start to see our amplitude. Our amplitude goes from 1 up to 3, goes from 1 down to -1. That's still an amplitude of 2 both directions, and then we get back to 1 again. So let's try and sketch that in now that we've visualized. Oh, that'll be handy. Okay, so we'll say that you don't always have to put this dash line in. I just find it makes it easier. Okay, I'm going to say that's 1. We could label it as y equals 1 just to help out. Now, we know our first point is 0, 1, which we've got. We know it half the period will be back at the same point. That was 1. Here is pi 1, and then at the end, oh, that's pi on 2, 1, and then at the end of the period, it'll be back there again. We then have our endpoint. We've put in our endpoints. We have our X-Intercepts. So let's mark those in. We've got 7 pi on 12 and 11 pi on 12. 2, let's call it 3. This will be -1. Okay. And from this little sketch, we know halfway, but so there's the halfway point. So at the quarter point, we'll be at our peak for a sine graph. And we have that. And then at the 3/4 point, we have our trough. Like that. And there's our graph. Okay. So the thing to recognize is that you can visualize the standard graph like this with no vertical translation. What's its period? What's its amplitude? Okay. And then you're going to take the whole graph and then just shift it up. Right. Here's another example. So sketch the graph of y equals 2 cos 2x plus pi on 4. We're going to ignore the plus pi on 4. For x is the set between -pi and pi. Okay. So amplitude we can read off is 12. Our period is 2 pi on n, where n is equal to 2, which is this bit. The 2 pi on 2, which is pi. Okay. So we can scrub that off. Okay. The endpoints are -pi and pi. So if we substitute that in, and I'm just going to fix this one up, we get cos of 2, and then 2 by negative, so that's going to be negative 2 pi plus root 3. Okay, so cos of negative 2 pi, so negative 2 pi is just going around the circle back to the start. What's the horizontal component? That's going to be 1. So we get 2 times 1 plus root 3. So we get 2 plus root 3. 2 plus root 3. Okay. And since we know the period is pi, well, between negative pi and pi, that's going to be 2 cycles. You know that from the period. That's how these are the exact same value. Okay. So X-Intercepts working domain. So if we have y equals 2 cos 2x 3, let alpha equal to x, follows on x is equal to, oh, no. Okay. For this working domain, we substitute in, we get alpha is the element of negative 2 pi, substituting these points into that, 2 pi. Okay, that's our working domain. So find our x-intercepts, we let y equal to 0, so we're left with negative root 3 equals 2 cos 2, oh, no, we'll let that alpha now, so we get cos alpha is equal to negative root 3 on 2. So we need a horizontal component of negative root 3 on 2. So a little sketch. The horizontal distance of negative root 3 on 2. The only way we can get it would be lines in quadrant 2 and quadrant 3. Now root 3 on 2 horizontal, that would be that angle in there is pi on 6. Okay, so alpha is going to be equal to pi minus pi on 6, or pi plus pi on 6. If alpha equals 2x, it follows on x is equal to alpha on 2. Oh, I haven't done, that was just between 0 and 2 pi, but I also need to look back at negative pi, sorry for my angles, my allowed angles. So that can also be, let's rub some of this out. That could be, if I went round, I could go negative pi minus another pi on 6. That would take me that line. Or I could also do, I could go around this way again. I could go around negative pi, but then plus pi on 6. So my alpha angles are 5 pi on 6, 7 pi on 6, negative 7 pi on 6, and negative 5 pi on 6. Okay, if alpha equals 2x, it follows on x is equal to alpha on 2. Therefore, x angle would be 5 pi on 12, 7 pi on 12, negative 7 pi on 12, and negative 5 pi on 12. Now, written in order from the earliest to the latest, for our domain, we would have x is equal to negative 7 pi on 12 is the first, negative 5 pi on 12, 5 pi on 12, 7 pi, 12. That's the order. Right, okay, so need to update some of the information. That was 2 plus root 3 for the endpoints. 2 plus root 3. 2 plus root 3. X-intercepts were negative 5 pi on 12, 7 pi on 12. Okay. Rightio, this one's a hard one because we're going all the way from effectively negative pi to pi. Yeah, that's what that is. But we've got intervals of pi on 12, so if we did that, that means we'd need 24 blocks, which is a bit hard. So then we're going to have to make, we don't have 24 blocks across. We would want, we had one block is equal to pi on 12. We need 24. But we can't do that, so let's let one block equal pi on 6. Okay, plus root 3, so it's translated up again. Have that. What's that? Okay, so 5, 6, that's pi. 6, that's negative pi. That's negative pi on 2. Pi on 2, so we can fit it out domain. Now we're up plus root 3. Okay, so what's root 3? We need to estimate that that's a 1 point something. So we can put in marker y equals root 3. So that's what we're going to be oscillating about, yeah? Okay. That's that vertical translation. Now we can start substituting in endpoint negative pi 2 plus root 3 because the amplitude is 2. So that's going to be 1 point something plus 2 is going to be 3 point something. So that's up there. That's negative pi 2 plus root 3. Next endpoint is pi 2 plus root 3. Okay. Now we're going to a cycle is pi. So going from negative pi to 0 is going to be one cycle. So we know that straight away. It needs to be 0, 2 plus root 3 because through one cycle we'll end up back at the same point. Rightio. Now let's try and fit in these intercepts. So each one's going to be pi. Each block is pi on 6. So half a block is the pi on 12. So right there would be, move it over, but that's negative 7 pi on 12. I'm marking a different color just so it's easier to see. Just there will be negative 5 pi on 12, and then we get the same thing over here. 5 pi on 12, 7 pi on 12. Okay. To remind you what a cos graph looks like when it's not translated anyway. One, big one. So we have the period, so that's part 4. Normally 2 pi, but halfway, yeah? Okay. That's half. That's a full period. So halfway between pi and negative pi and 0 would deal with the left hand side. Between negative pi and 0 gets to its lowest point, which would actually be root 3 minus 2, which is down right about there. So our graph comes through like that, and then it's going to repeat again. Like so. Okay. Now, my lines aren't very great using this digital tablet, but you get the idea. So we need to label all our intercepts. That one's done, so we just need to label our X-Intercepts properly. So that is 7 pi on 12, 0, 5 pi on 12, 0. Same thing in here. Negative 5 pi on 12, 0. Negative 7 pi on 0. And there's our graph. So there's a lot to it. Once we start translating, it becomes real particular. There's some skills you really need to have down pat for you to be successful in this. You need to, one, recognize key. Let's go back to here. This, okay. You need to be able to recognize the key parts of the graph, amplitude, and that affects period, and then finding your vertical translation. You need to be able to recognize your amplitude and your period. You then, from that, need to visualize the standard graph. Okay, so you need to know for sine, it looks like that with your period, or for cos, it looks like that. Again, your period, and that will be positive A, that'll be negative A. Again, same here, that'll be A, that'll be negative A. You need to be able to visualize that. Okay, then define the endpoints. Find the endpoints, you need to be able to solve. Okay, solve the equation using the domain. Okay. You need to be able to find your x and y intercepts again, solving the equation. So within solving the equation, that is, for example, all of this. Okay. And within solving the equation, you need to recognize the symmetry within the unit circle. Okay, so that's going right back to the start. And if you're still struggling with the symmetry of the unit circle, which is like the most fundamental part of this whole topic, then you need to go back and really revisit that, because you can't fluff your way through it. You're not going to be able to. And then after all of that, you then need to be able to graph by connecting the dots. Okay, so there's a whole lot in there. It's bringing together all the previous topics: solving equations, solving just circular identities, exact values, symmetry within the unit circle, and then graphing, and then period and amplitude. It's bringing that all together and finally graphing that. So you can't do the graphing easily and efficiently if you're still fuzzy on the other section. So you need to go back and practice. That's it for 14J. If you have any questions, ask in class.